We are discussing calculus in our classes. We have done limits, continuity, and differentiability. Then we learned about differentiation. And then we also discussed about the application of differentiation, that is, application of derivatives. Now we are going to discuss another operation, which is kind of similar to differentiation, but is opposite in nature to the differentiation. What we used to do in differentiation is that we were differentiating the function. We were like breaking the function down in parts, and we were looking in parts in very like small pieces, and like where h used to tend to 0. Now here, what we are going to do is completely opposite of nature. That we are going to look at the integration of function. We are going to take some parts, or like we are going to take a function, and then we will integrate it in some limit, or in this chapter indefinitely. We will integrate some function indefinitely, and the answer which would be coming after integration, that would also be indefinite, which will not be fixed. We'll come to know later in the discussion. So there are two type of integrations: indefinite and definite. Indefinite, where we are not having any limit on integration, it is limitless. We are integrating the function. Okay, and there will be some constant for that, so to represent that this is an indefinite integration. When we will discuss definite integration, we are integrating the function in some limits. So the answer of that particular function would be somewhat limited. Okay, so like, let us say this is some function f of x plus c. Okay, and if we are derivating it as we have discussed earlier, so while derivating it, the differentiation of this, let's say it is represented by capital of f of x plus differentiation of c is what? 0 as per x. So this is what things look like while differentiating it. And if we like take this, okay, and this is known as integrand, and if we integrate it, like we are integrating the functions variable of x, of like every small dx is what is small x. So we are like taking this function and integrating the very small part of x in this. Then it will come out as same. After integrating, the function will become this one. C. C is the constant of integration, because as in differentiation, the differentiation of c is 0. So we are not sure that what the constant was while indefinitely integrating, right? That's why we will write it as c only. It can be 1, 2, 3, 4, 5. We don't know. Okay,
Yes, sir.
and this this is known as the derivative. And if we have integrated in, so the function which will be coming, it is known as antiderivative. Or we can also call it as primitive. This operator is known as integrand. We have discussed about these terms. So these are some properties of integration. indefinite integration, whenever like there are two functions in addition or subtraction, then we can separately use this operation on both of these two terms. Whenever some constant is getting multiplied, we can just simply write it in of the operator, and then we can go ahead with the integration. Differentiation, both of these operations are simultaneously happening on a function, and they will both neglect each other's effect. The function will remain the same, but there will be a c, there will be constant there. Of course, the function will get first integration and then differentiation. So it's debatable, and it depends whether the constant will be there or not, that which sign is first. Like if we are discussing about integration of f of x and dx, in this case, what will happen? So first step, integration will happen, let's say f x plus c. Then differentiation of this, again, this become differentiation of c0. So in this case, this is going to be the solution. Let's discuss for some other. Let's discuss if this was the case of f of x, then differentiation is then integration is given. So written it otherwise. So it will become first f of x, and then its answer would be f of x plus c. So yeah, depends which operation is first or ahead, but you got the gist about, right? Both of them will be canceling their effect, but you have to note down that which operator is written first, or what is the order. We're discussing next property, f x raised to power n into f of x into dx. So its integration will be like this: f of x raised to power n plus 1, where uh, I'll discuss this later. It is simple, self-explanatory, and its derivative will be written in the denominator part. So let's first discuss about basic integration. Like in differentiation, what used to happen, we are differentiating this function. So exponent will be written ahead, and the power will be subtracted by 1, and the same will be written down. Okay. But in the case of integration, we now the power gets added. The same is divided by this. Oh, sorry. Okay. So in differentiation, what was happening? The power is getting subtracted, and the actual power was written ahead. And here the power is getting added. Okay. And the power will be written in the denominator part. So here now you can see the function, and it have to be this. This is the example of substitution. So we'll discuss these later. Like integration by substitution. So these are some formulas of integration, and we can relate them with differentiation. Like the differentiation of logarithm of x is 1 by x. And now here it is written 1 by x differentiation. What is 1 by x? X raised to power minus 1, and its differentiation. So if we go by the actual formula, just in case, so what will happen? 1 plus 1 upon minus 1 plus 1. It should be the integration, right? Then x raised to power 0 upon 0 plus c. So this is like 1 by 0 infinity. So this is like not defined by this formula. So the formula comes out to be logarithm of x. Otherwise, we can also prove it by taking the reverse case, that whenever we will differentiate logarithm function, logarithm of x, then the differential will be coming out as 1 by x, right? Differentiation of exponential function e raised to power x is a stubborn function. It do not changes in integration, it do not changes in while happening differentiation. Only thing is to note, only thing to note here is that if e raised to power ax is given, so e raised to power ax will remain the same, but its derivative will be written down in the denominator. Whereas in the case of differentiation, we used to write it at we used to multiply by the derivative. Why it is happening? So we will discuss in the integration by substitution part. Okay. Is everything clear?
Yes, sir.
Yes. Exponential function a raised to power x, and it's like logarithm will be divided. Sine of x, cos of x, x square of now here you have to remember one thing only. The formulas of differentiation are getting reversed. Okay. The formulas of differentiation are getting reversed. Earlier, we used to use a trick that differentiation of any trigonometric function starting with c will have negative sign in front of it. But now it is otherwise. That differentiation of anything, sorry, now integration of anything, if the function is coming out to be starting with c, then the answer would be having the negative sign. Okay. Otherwise, in the differentiation case, the c must have been in the like differentiating function, whereas it is now in the integration, the c must be having in the must be at the right hand side, solving the integration after solving the integration. Okay, is that clear? Is this trick clear?
Yes, sir.
We'll see an example also. Like if we are like integrating sine of x, then we will be having our integral as minus cos x because c is there, and again wherever you can see c, then there is a negative sign. So this is a simple observational trick which you can uh, have in mind to remember these formulas better. So integration of sine of x is minus cos of x. Integration of cos of x dx is sin x sec square x tan x, because differentiation of tan of x was sec square x. Differentiation of cosecant square of x is sec of x minus cot of x. And differentiation of sec x tan x is sec x, because differentiation, sorry, integration of sec x tan x is sec x, because differentiation of sec x used to be sec x tan x. Now integration of cosec x cot x is equals to minus of cosecant x plus c. Integration of cotangent x is equals to logarithm of sin x, and tan of x is minus logarithm of cos x. You can remember by this, like c is having cot x is having sin x, and tan x will be having cos x. Like cot can be written as cos by sin, tan can be written as sin by cos. So they both are having the trigonometric function which is in the denominator part. So you can remember by this, and don't remember, sorry, don't forget to use this negative sign. And also note there is a modulus with logarithm here. So are all these formula clear to you?
Yes, sir.
Then let's move ahead. And please don't be like, don't get scared and don't be afraid of these formulas. These are very simple and logical formula. You just have to like try write them and learn them. You can learn them by writing, and you'll be easily able to cram all these formulas using this technique. And I'll say cram only because it's the only word which we'll be actually doing. So don't like try to write all the formulas on in once. Try to like learn them in parts. Like let's say first I'll learn only six trigonometric integration formulas, six trigonometric integration formulas. Then I'll learn let's say six another inverse trigonometric formulas. And then I'll learn these spatial forms. Yeah. So divide them and learn them in parts so that you'll be able to see small part of problem in front of you, and you'll be able to have more confidence and belief that you'll be able to learn them. And they are very simple, very logical, very logical, very logical. You'll be able to learn them easily. So integration of secant x is logarithm sec x plus 10x, and which can also be written as 10 pi by 4 plus x by 2 log of cosecant x. So here the minus sign is in front of cot x. So you can note that. And these are inverse trigonometric formulas, whereas we are seeing like integration of dx upon square root of a square minus x square is equals to sine inverse of x by a. So you can like after seeing all these formulas, you may be wondering in your head that wherever we are writing any derivative of the function, we are writing in the denominator part. Here also in the denominator, a is in the denominator, 2a is in the denominator. Okay, so you can make this observation and help yourself to learn. So this is the formula x square plus a square is 1 by tan inverse of x by a. And this is secant inverse formula. And these are some very basic formulas which are very, very useful when you will be learning about the area bounded by curves. So, and they are also favorite in PYQs. So these are like all important formulas. Every formula is like a tool which you will be using while solving a question. So your tool must be very fine to you, and you must know your tool well. Okay. So learn all these formulas. There is particularly pattern in these formulas. Like let's discuss about these three formula. The same is written here. The same is written here. And a square minus x square. So this is somewhat similar to sine inverse of x. So here it is that this is similar to this. This is similar to this. This is similar to this. This here, like there are only like remaining things, and these all three are similar. So this is whole is like you can remember them just by understanding the formula. Now about this can be related with this. Okay, wherever like a square root of a square minus x square is there, sine inverse can be discussed, and like this can be, and other in other cases there is logarithm, and wherever x square is different, don't forget to have this negative sign. So this is how you can make observations, and you have to learn them by writing. Write again and again, you'll be able to learn them in a very easy manner. These
Yes, sir.
formulas, and basically one more trick. Yeah. So one more trick, x square minus a square, x square minus a square. So this is similar. This is similar. And same goes with these. X square, x square, same goes with this. Okay. So you can relate them and learn them by this. So you have to learn it. There's no other way. And you can learn them easily by making these patterns, observations, and using logic questions. Okay? Any other doubt at how to learn it? Or something?
No, sir. Actually, will I will today night I will follow your rules, sir. If I will raise any doubt, I will definitely ping you also.
Yes. And please, like, keep on revising the notes after lecture.
Yes,
Make your notes
yes, sir.
and revise those notes and practice them by writing them again and again, and also practicing questions from like examples from some books you can use. NCRT also is a very, very good book and basic book if you are struggling with the basic level, and it is also a book which makes your level.
So
So this is really important property which is favorite of UPSC, and they ask a lot many questions on this. Okay, it can be better understand by writing it this format also first. Yes, Tanish.
No, sir, by mistake.
So this is a very important formula. I have just like replaced ax plus b with this to make you better understand this standard form. So whenever something like exponential function is getting multiplied with f of x plus its derivative, then you can just simply write it as e of x into f of x. And this is used in many previous year questions. Okay. So shall we discuss some examples? Let's do them. We have to evaluate this function. And while I will be making calculations, please unmute yourself and keep on asking or keep on telling, like, okay, sir, this will be this will be this. Okay, so let's solve this.
yes, sir.
So we know integration of x raised to power n dx is is x raised to power n plus 1 on n plus 1. And here is an is this also. This is basically logarithm of x plus c. This is plus c also. And simple. We can also learn this, the formula of square root of x dx. This is basically half. So 3 raised to power 2, 3 by 2 plus c. You can learn this because it is very useful most of the time. And dx upon root of x, because root of x is there in the denominator. So x raised to power minus half plus 1 half plus c. So 2 root x plus c. Yeah, right? Okay. So these are the formulas which we are going to use. So let's use this one. So this operator will get separately divided. We can write it as dx plus 5x square. So this is basic property. This question is based on very basic property. That first we can like divide the function and write the operator with each and every each and every term. And here we have to notice this. We have to mention. I have to mention that here the differentiation of a constant. The differentiation of constant c dx is not 0, is x plus c. Okay, because what we are doing here, what we are doing here is that differentiation of any constant. So we can write the constant outside and dx. So basically, if there is one dx, like we can write one here. So one can be represented as this. and then c into x raised to power 0 plus 1 upon 0 plus 1 plus c, right? So this will become, let's write the constant differently because we already have seen the calculation. So c into x plus c dash, right? C dash is the constant of integration. C was already there. Is this clear?
Yes, sir.
Coming back on our example. So now we can write the constants outside, otherwise we can also continue like this one. X is for 3 plus 1, so 4 by 4 plus some constant. So let's write, let us write all the constants separatively, and we'll see what we can do. Okay, let's write here only to better understand. 5 into x 2 plus 1 upon 3 2 plus 1 minus 4 into dx, which is x. Also, I forgot to mention the constant of this plus constant of integration of this, then minus of 4 into x minus of constant plus 7 logarithm of x plus constant, some constant, and plus 2 into 2 root x plus some constant. Okay, so we can now write and simplify it. Plus 2 into 2, 4 root x. And all these constants like c1 plus c2 plus c3, sorry, minus c3 plus c4 and plus 2c5 will also be equal to some another constant. So let us say that constant c. So let's write plus c, okay? And we can also, अपनी सहूलियत के लिए, for our convenience, we can also let the constant in logarithm value. Okay, if it is convenient to us, contract of convenience. Yes. So is this clear to everyone that how it is, so how we have solved this question?
Yes, sir.
Okay, then let's discuss another example. Before going up further, please look at the formulas used once again. Observe this. Okay, let's now discuss another example. Evaluate 2 raised to power x plus 3 raised to power x upon 5 raised to power x to dx. Okay, so this is our question, and let's first simplify it so that we'll be able to see which formula we can use. Divide and write it. Yes. We can write it as like this, like, right? Everyone agrees? Everyone agrees?
Yes, sir.
Let's divide the integrand also. Now we can see a pattern that we, in formulas, we discuss about the integration of this. It is this only. Integration of exponential function, it is ax is divided by logarithm of x plus c. So now here we can see like the constant is there, and it is also an exponential function. So let's use the same formula, and 2 raised to power 2 by 5 raised to power x divided by logarithm of x. Logarithm of x or a? I guess a. No, I know. I don't guess. I'm sure it's a. Logarithm of a. So here also ln 2 by 5 plus 3 by 5 raised to our x and ln 3 by 5 plus some constant will be there. So yeah, this is our answer. First, we have simplified this question. Then later on, we just integrated using the formulas which we know. Is this clear, everyone? Tanish, Raja Krishna.
Yes, sir.
Yeah. So we have just used these two formulas in this. Learn them. Done?
Yes, sir.
Another example you can take is 1 plus sin x or 1 minus cos x. See, understand this thing. Your ability to simplify, your ability to, and your acquaintance with trigonometric functions and algebraic function, and your basic understanding of how algebra works is very, very eminent, very important for you to solve complex questions of other chapters like calculus or even its differentiation or other questions also. Because at the end, what is a complex question? It is a simply collection of multiple simple concepts from different chapters according to UPSC papers. Okay, they don't make much complex questions. They just mix up simple concepts from different chapters. They make a question which seems like complex, but if you have understanding of similar simple concepts of multiple chapters, you'll be able to easily solve them. So in this question, we have to evaluate this differentiation. So first we will do what? If we are not able to directly apply any of our prior knowledge of formulas or tools here, so let's first simplify the function so that we'll be able to solve this. 1 plus sin x on 1 minus cos x dx. So let's take this function out, okay? Then we will put other function back in this. So 1 plus sin x. 1 minus cos x can be written as 1 minus cos x can be written as, first let me write some trigonometric formulas, which is very important. Cos 2x can be written as cos square x minus cos square x minus sin square x, and also 2 cos square x plus 1. One minus 2 sin square x. No, actually, you made a mistake here. 2 cos square x minus 1 and 1 minus 2 sin square x. Okay, 1 minus 10. Let's just discuss about these two formulas. So from this formula, we can write it as that 1 plus cos 2x can be written as 2 cos square of x. And if we just halve the angles both sides, 1 plus cos x is what? 2 cos square of x by 2. And if we like discuss this formula, so 1 minus cos 2x is equals to 2 sine square of x by 2. And if we halve the formula, simply 1 minus cos x equals to 2 array r. here it will be sine square x only. So 1 minus cos x is equals to 2 sine square of x by 2. Okay. So these are two very basic important formulas which we draw from the formula of cos 2x, cos double angle. Wow. So fascinating to do this kind of things like making drawings, but still I'm not good at that. Anyways, 1 minus cos x will be written as 2 sine square of x by 2. And now we can write 1 as sine square of x by 2. Let me write 1 only because you'll be then better able to understand it why we have done so. This we have written as 2 sine square of x by 2. Now 1 plus sine x, sine 2x. Sine 2x is what? 2 sine x into cos x. And if we just half the angle, so what we can write it as 2 sine of x by 2 to cos x by 2, right? So simple, 1 plus sine x, it will become 2 sine x by 2 into cos x by 2 upon 2 sine square x by 2. Now one is what? If we go back in class 10th, and we have only learned only three trigonometric identities. That is sine square of theta plus cos square of theta is equals to 1. So we can use the same here. Whereas if we use theta as, if we will substitute theta with x by 2, then we'll have more convenience because of our given expression. So now let's write sine square of x by 2 plus cos square of x by 2 plus 2 sine x by 2 cos x by 2 upon 2 sine square x by 2. Okay. Now what we can do is we have already simplified this form this function. How? So let's divide the numerator by denominator, and let's go ahead with our discussion. So yeah, sine square of x by 2 upon 2 sine square of x by 2, it will become half, nothing, plus cos square upon sine square, it will become half, another half into cos square of x by 2, plus it will cancel sine x by 2, and 2 also will be cancelled. Cos x by 2 upon sine x by 2 will become cot of x by 2. So have I made any mistake, or is it correct now? Yeah, I guess it is correct. Okay. So let's bring, but why we have written one is this. There's no much convenient use for doing that. We have simplified, like we have simply written as 1 by sine square of x by 2 would have simply written as half into cos square of x by 2, right? So let's do that only. Oh, we have to simplify now further. Okay. So half into cos square of x by 2 plus 2 will get cancelled by 2 sines 1 degree of sine x by 2 will be cancelled, and cos x by 2 by sine x by 2 will be written as cot of x by 2. So this is our function. Let's once again write the integration because we have simplified it now. Okay. So now the integration of cos square, sorry, this is cosecant square. So the the integration of cosecant square is cot x. So simply write cot square of x by 2 into the derivative of x by 2 in the numerator part, in the denominator part, sorry. So 1 by 2, 2 here, then plus integration of cot x was logarithm of sine x. So here sine x by 2 into there was half with this, or no, there was no half with this. So into the differentiation of x by 2 in the denominator. So into 2, right? And plus the constant of integration. We can further simplify it as this. So cot square of x by 2 plus 2 logarithm of sine x by 2 plus c. So this is our answer. Is this example clear, everyone? First, we have just simplified this function, and then we have simplified this function in the terms of, in such terms that whose integral is known to us. Using our formulas, we will be able to easily solve them. Is this example clear to everyone?
Yes, sir.
Okay, great. So what lies ahead? Geometrical interpretation of indefinite integral. So as we have already discussed about indefiniteness of an integral, whereas if we are different, like integrating some function, so there will be a constant which is not known to us because it is indefinite. So fx plus c will be representing a family of curves, right? Where it can have like the constant value is 0, so 1 plus 1 plus 2 or like plus 3, or also the constant value minus 1 can be minus 2 minus 3. Okay, so this is representing a family of curves because C is indefinite to us, and it will be definite to us once we will have certain other conditions, or we will be discussing about definite integration. Is this clear, everyone?
Yes, sir.
Great. So shall we discuss one more example? Okay, let's understand this.
Yes, sir.
Integration,
Yes, sir.
yeah. Integration of the form f of ax plus b. So this is basically trying to say that the function is having, and it's like input is having another function. Okay, so we'll be simply multiplying, like the derivative will be simply getting divided, and it will be written in the denominator part. Like a is written in the denominator part, here also, here also. Make this observation. That's the only thing which is this statements are trying to tell you. Is this clear, everyone?
Yes, sir.
Yeah. Integration by substitution. This is very important, and this is kind of like a technique to solve integration. Okay, so in this, what we are trying is that if we have to integrate some function, and in that function there is another small function and its derivative is also there, so we can simply let that smaller function, like if there is a function and its derivative is also there, so we can like take the function, the smaller function as t, and then derivate it, and will replace the variable from x to t, and then can be written as it is simplified here because f of x we have differentiated in this with on both of the sides. So dt by dx, what it will become? F dash of x is equals to dt by dx, right? So further dx can be multiplied to the left hand side and can be written as this. So now we have substituted f dash of x into dx as dt. Dt is there, and f of x is d. So now it is simplified version, right? What we were earlier discussing. It is a simplification of the function where we now know the formula of this, and we can directly use our formula logarithm, and then we can back substitute t with the original function to have our final answer in terms of x. Okay, is this clear, everyone?
Yes, sir.
Yeah, here also it is somewhat similar. You'll be able to better understand it when we will discuss about formulas, about, sorry, examples. Okay. So this is basic example. You can learn, you can understand this, that there's a function and there's a square root also. So we have let this function as t, and later we have substituted this f dash of x with dt. Dt is there, square root of t. Now we know its formula. Now we can solve it using our formulas, which we learned earlier in this chapter. So we can just simply use that, and then later we can substitute the t with our original function. Okay. Is this example clear, everyone? Yes.